Hello again and welcome to my workshop. As you may have noticed, it's December now, so we're leading up towards Christmas. So today we're going to do a CNC routing job. It's actually the coat of arms that we put together in ATCAM standard on the last video. So if you want to know how to put not put a 3D relief together, but take a 3D relief straight off the internet and clean it up using ATCAM to be able to machine it and indeed create the G codes. So we'll move over to the Pacific Tooling 6012 CNC router. So this is a Pacific Tooling 6012 CNC router. This is my personal machine made to my requirements. It's equipped with a cooling system, which is what's known as a stainless steel tank. So this is actually waterproof. So you can cut metals, aluminium and what have you. It's equipped with a 2.2 kilowatt spindle or router head. Also, this machine is quite special that it has servo drives on every axis. So that's just a rough rundown on my personal machine. Now a lot of people are asking me about my waste sheet. My waste sheet is made up of two 3/4 inch MDF boards. Now the bottom sheet, which these clamps actually clamp in, is a complete sheet. Now the top sheet is screwed to the bottom sheet with these areas just routed out. So all I have to do is, when the top sheet is worn out, I just unscrew it, and these screws are set in approximately 1/4 inch, 5mm, further on down in. I don't expect to machine through into my waste sheet more than about 2mm. I'm fairly careful in how I set the programs up so the tool does not go through any further than really 1mm. So I don't want to hit any of these screws. Obviously accidents do happen, but I try to be really careful. So the bottom sheet is actually held down on the aluminium bed here, and also there's a rubber bed underneath that. So all I need to do really is just unscrew these screws, lift the top one off, route out these particular areas and put another sheet on, screw it on, and it's done. Also, I have lines, parallel lines, some of them are worn out actually, in strategic areas, so I don't have to worry too much about getting material square. I can just put it on here like this, line this edge up with the material, with the line on the waste sheet, and screw it down. It's as simple as that. This particular job too, you'll find different types of wood, or the grain of different types of wood, when it's being cut with a CNC router, react in different ways. Now I know this is Tasmanian pine, and I'm going to be cutting in the X direction. So I know the grain pattern really needs to go along in the X direction, and that actually cuts down more than 50% of any furring that's left by the tool when it's finished its finishing cut. So it makes life a lot easier for you. It gives you less work to do. And if you're in production, obviously that's a time-saving thing to do. So you'll learn all these things, little tricks, as you start machining. So another thing too, because I screw things directly into my waste sheet through the material, when you have finished a job and you take your remaining parts off, you find that you get a raised area where the screw went in, where the screws pulled the material up. So if you put a new piece down on like this, it's going to hold it up. So what you need to do is just get a bit of rough sort of emery. I use old discs that I've used. I don't throw them out that often because they always come in handy. And for doing jobs like this, there it is, flat again. So that's another little tip. So now we'll mount this on here, away from the screws. We'll just line this up with that line and screw it on. So most of you now are familiar with Mach3. If you're not, you will become familiar. So we've used ArtCam in the last video to clean up this coat of arms and prepare it for machining and write the G codes for the two different tools. We're going to be using this tool here. This is a tapered end, ball mill. Actually, it's a 2mm ball on the end, and this is, I think, 40mm long cutting edge. These are the best ones to buy. Don't buy the straight ball mill cutters, because you'll snap a lot of them and they flex and vibrate, and you're very limited to the speed in which you can run the feed rate, because they'll snap off. So we're using that one, but for a roughing cutter. For a roughing cutter, we're going to be using a 12mm 3-flute end mill, and I'll show you how to change a tool in a minute, and how the chuck or the collet chuck operates on the spindle. So first things first, we're going to put the G code into Mach3. So we're going to come up here, File, it says Load G code, and these are them here, removable disc, so we know it's the right drive. And first of all, we're going to put the 12mm in there, and there it is. Now you will notice in Mach3 the G code, which is seen as an actual picture in Mach3, is come up front over on that side. So it's all over here. I'm off camera there a little bit, but it's all over on one side. We're going to put all that right in a minute when we zero the cutter to the 0 point of the work. So I've just shown you now how to put a G code in. This is what G code looks like. It's three-dimensional coordinates, like coordinates on a map, except you have X and Y on the flat plane, and the Z, which is the three-dimensional part of it. So the computer will deliver these lines of code to the Mach3 CAD inside the machine. Thousands of lines, yes, nearly hundreds of thousands of lines per minute. Okay, so with this machine, I've had it supplied with a radio controlled device, or an MPG. So what this does is it's a radio control device to move the machine around. So what we're going to do, we're going to bring the gantry all the way up to the front, to near what they call the home position, which is right here at the front, which is the best area to change a tool in the chuck. So you can move it quite quickly. And incidentally, for the guys out there are more familiar with these machines, you'll probably be asking me questions about why I've got the dust shield off. It's much easier for me to change tools and show you guys, or the guys that don't know too much about these machines, what's going on and how to do things with the boot off. Under normal circumstances, when I'm running the machine, I always have the boot on, because the dust from things like man-made wood, MDF and things like that, and plywood, there's resins inside this that are carcinogenic. So you know, these machines, you've got to take protection. You should really run it with a dust collection system and a mask as well. I mean, I just run this for a few minutes here and there without this system on, but I'm still very, very careful. So we're going to bring this up all the way to the front now, or near to the front, and we're going to change this tool. Okay, so what you require with these particular chuck, which is commonly known as a collet chuck, is you need 2 spanners, which we supply. Incidentally, Pacific Tooling is my company, and I manufactured these rotors all the way from 4040s right up to sky's the limit, really. But our main ones are up to 3 meters long, cutting bed, by 1300 wide. That's the, and everything in between. But we do sell the 6012s more often than not. Probably 60% of the machines we sell are the 6012s, because it's about the right size. It's a quarter sheet. It'll process a full quarter sheet, which is a very handy size to have. So what you do, if I can get the right size spanner on there, is just tool's going to drop out of there. There we go. And that's one tool out. This is just a facing tool that we use to just face off material. I'll take this off and show you exactly what's inside. So inside there you have it's a dual taper. Okay, and there's a taper on the bottom side of this nut. And there's a taper up inside here. So when this nut squeezes this up inside here, it collapses down and grips this shank very, very tightly. Much tighter than what you can with a chuck, as it were, on a drill, that type of chuck. So that just clips into there. Your tool then slides up into there. In actual fact, this is a 12-inch shank. So and this one is a 1/2-inch shank. So it's actually slightly bigger. It's 0.75 millimeters, too big for what we actually need. So we'll just change that. Put that one in. See, nice snug fit. It'll hold in there. And you need to put the tool all the way through. So this is gripping the full part of the shank. If you need more to be stuck out to do a deeper cut, you're using the wrong cutter. You need an extended cutter. So that's the correct way to put a tool into the collet. And then you just screw it on. And another thing too, you don't have to over tighten these. A lot of people over tighten them. It's just that. That's all it is. Firm. Quite firm. That's all that's required. So now we are going to set this tool up to the 0 point, or the work offset, which in the language is G code and Mach 3 is the G54. That's the actual naming for it. G54 offset. Okay, so what you do is you bring what you're looking for is to bring the center of the tool to this mag. This is the start point of the program that I've selected anyway. So you just carefully, okay, bring it down. Z, very, very controllable. Y, you can have it working very, very slowly if you wish. Now you can, we're working with wood here, and within a millimeter is okay. It's, you know, it's not going to be, I mean, you can get it very, very accurate if you wish, but for our purposes, doing this three-dimensional cut, it doesn't need to be really accurate, but close is fine. So let's go down a bit. Now this is just setting the X and the Y at the moment. Okay, so now I can see that, yeah, probably it's pretty well there. Back that way just a little bit. So that's Y and there. Okay, so now we're going to set the, could come that way a little bit as well, eh? That'll do. That's pretty good. Now these numbers on here at the moment don't really mean anything. This is just left over from the last program, and I've just been jogging the machine around. This is called jogging, by the way, moving the axes. It's called jog. Okay, so now what we're going to do is zero this position in Mach 3, and I'll show you how to do that. Very simple. You just get the cursor and you come up here to the X and Y, and you just press on this box. That's the X, and notice it's all gone to 0, and the Y is 0. Now the Z is an entirely different thing. Now that is done automatically on this specific tooling machine. There is an automatic tool setting device. Okay, so all we do, you'll see that there's many different numbers on here. Now many of the keys, you'll see there's a blue section and an orange section. This means that they have a dual function. And in this particular case, we're going to use the probe Z function, and to operate this orange function, then you have to press the FN, which is function button. So this is the Z height setting tool, It's magnetic and it sits or lives on the side of the cowling there. So what you do simply is press the function and probe, and this will gently come down. You just hold it on top of the material underneath the tool, and it will register exactly okay. So now the system has been set up. I have actually just moved the gantry back up to its home position where it normally lives. So now what we're going to do is regen, okay, the tool path. In other words, we're going to put this in the correct location now, and it's simply done by pressing the regen tool path button, and there it is. It is in the right position now according to where the material is and where the 00 or the work offset actually is on our PT6012. So now we are ready to do the roughing cut.